In this video, we're going to look at equivalent statements. We've discussed these before. Remember, in terms of truth tables, if two statements have the same truth tables for their final result, then they are equivalent statements. But we're going to take a look at a few examples. Let's take a look at some English examples and see if we can figure out, are there any statements that say the exact same thing? So, starting off, we have P is Romeo loves Juliet, and Q is Juliet loves Romeo. So we're going to translate each of these four statements into English. So we have not P and not Q. So that would be Romeo does not love Juliet, and Juliet does not love Romeo. For the next one here, we have Romeo does not love Juliet, or Juliet does not love Romeo. The third one, we have, it is not the case that Romeo loves Juliet and Juliet loves Romeo. And lastly, we have, it is not the case that Romeo loves Juliet or Juliet loves Romeo. Our job is going to be to figure out which of these statements are equivalent to one another, which of these statements say the same thing. And so we're going to take a look at part one, which is an investigation, and we're going to figure out which statements below are logically equivalent, which ones have the exact same truth tables. And we're going to make those truth tables to show and prove that these statements are logically equivalent. So we've done this before. We're going to fill them all out again. I'm going to suggest that you pause and try and do them on your own. I'm going to do them all and then pull up the screen so you can see the final result. So filling out these truth tables, again, I use the traditional way that the book shows, not the alternative way that I actually prefer. You can see I did the original P and Q truth values in light gray, then I evaluated their negation if necessary in the first two with a dark gray, and then I evaluated the final result in red for each of them. Same thing for the last two. I did the P and the Q in light gray, and then did the conjunction or disjunction in the dark gray, and then I negated it and got the final result in red. And so looking at that, we can see that this statement here, which has a truth table of FFFT, or false, 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 true, is the same as this statement right here. False, 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 true. And then the ones in the middle, not P or not Q, had a truth table of false, true, 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 and not quantity P and Q has false, true, true, true. And so this is actually our De Morgan's law. We've seen it before. We saw it with the set theory, with the intersections and the unions. And the complements got distributed to the different sets, but it changed the type of whether it was a union or a intersection. So here we can see that right now. Let me give myself some space. If I have, or I guess space above, if I have, let's do this one right here, not P and Q, you can think of this not as being distributed to the different simple statements, but when you do that, this changes to an or. So we get not, these are equivalent to not P or not Q. So one thing to look for with De Morgan's, and a lot of us miss this in the set theory one, is that if the negation, or in terms of set theory, if the complement or the negation is distributed, it changes the type from one to the other. So in this case, the or the and changes to an or up here. In the second case, the or would change to an and when that negation gets distributed. And that's kind of like a mathematical way to describe it. That's how I see it. I see that negation being distributed into the parentheses, almost like the distribution law. It's not exactly like that, but that's how I see it. So if you see it another way, that's fine. But when I talk about distributing the negation, which is, I guess I could say technically not what's actually happening, but that's what it looks like to me, and so that's how I refer to it. So we're just going to formalize the De Morgan's laws for logic, and it's essentially that the negation of the conjunction is equal to the disjunction of the negations. And the negation of the disjunction is logically equivalent to the conjunction of the negations. So if you see here, the operator changes and the negation distributes. Okay? Using what we did from the warm-up, we have our P and Q. Romeo loves Juliet is P, and Q is Juliet loves Romeo. We're going to write the statement that was provided symbolically. We're going to use De Morgan's law to write an equivalent statement symbolically, and then we're going to translate that equivalent statement into English. So we have, it is not the case that Romeo loves Juliet and Juliet loves Romeo. So these combine together, and this is our negation. So that's going to be negation of P and Q. The equivalent one using De Morgan's law would be, I'll write it in black, not P or not Q. So that is Romeo does not love Juliet, or Juliet does not love Romeo. If you think about this, the negation is not the case that Romeo loves Juliet and Juliet loves Romeo. Essentially what that means is that at least one of them does not love the other. Or maybe both don't. But that's what's implied in this statement, and that's why that is a logically equivalent statement to not P or not Q. Okay, let's look at example 2. We have P is Atlanta as a city, and Q is California as a city. We're going to write the given statement symbolically. We're going to use De Morgan's law to write an equivalent statement symbolically. We're going to translate the equivalent statement into English, and we're going to determine if each of the statements are true or false. So we have, it is not the case that Atlanta is a city or California is a city. So we have a negation of the statement or the statement Q. So to write that symbolically, that's going to be negation of P or Q. We know that that's equivalent to the negation of P and the negation of Q. So let's write this out in words. For the second part over here, that would be Atlanta is not a city, and California is not a city. Okay, so let's determine if these statements are true or false. What about, it is not the case that Atlanta is a city or California is a city? Well, if we look at the equivalent statement, Atlanta is not a city and California is not a city. That's only true if both parts that I underline in purple are true. Well, Atlanta is not a city is false. California is not a city is true. It's a state. So therefore, because one of the parts of this conjunction is false and the other one is true, that makes this entire thing false. Because it's equivalent to this statement, we know that that statement is also false. Let's look at the next one. Atlanta is not a city or California is not a city. So that's going to be not P or not Q. That's equivalent based on De Morgan's law to not P and Q the quantity. So that is, it is not the case that Atlanta is a city, and California is a city. I don't know why I put that parenthesis there. Okay, so if you think about this, it is not the case that Atlanta is a city and California is a city. So we have to determine if that is true or false. Well, if we think about this statement, Atlanta is a city and California is a city, we know that that is false, but this is the negation of that, which is true. It is not the case that Atlanta is a city and California is a city because California is not a city. So this is a true statement. Okay, so I broke this down into the two pieces. Atlanta is not a city and California is a city. That is false because California is not a city. But then when we say it is not the case that that chunk is true, then since we say it's not the case that this false statement is true, then that makes this true. That's a weird way to say it. But you could just kind of write the truth under it. So this is true, this is false, which makes this false. But with the negation from that, the negation of a false statement is true. You could also just look at the original statement that we were provided. Atlanta is not a city or California is not a city. Well, this is false, but this is true, so this or statement is true. Now, remember from our previous video on truth tables for conditional statements, we looked at converse, inverse, and contrapositive. Remember, the converse is when you flip them. The inverse is when you negate them. And the contrapositive is when you do both. You flip and you negate. Okay. Let's skip to example 4. If I am in Houston, then I am in Texas. So we have two statements. P is I'm going to shorten it to I'm in Houston. Q is I'm in Texas. So the converse would say, we just flip them. We would say, if I'm in Texas, then I'm in Houston. The inverse would be, if I'm not in Houston, then I'm not in Texas. And the last one would be the negating and flipping. If I'm not in Texas, then I'm not in Houston. So if you think about this, is the first statement true? If I am in Houston, then I am in Texas. That is true. If you say the converse, if I'm in Texas, then I'm in Houston. Is it possible to be in Texas but not be in Houston? Yes, so that statement is false. If I'm not in Houston, then I'm not in Texas. That statement is false. Because if I'm not in Houston, well, that means I could be in Dallas, right? But if I'm in Dallas, then I'm still in Texas. So that statement would be false. If I'm not in Texas, then I'm not in Houston. That is true. So if I'm not in Texas, that means like I'm in Oklahoma or something. And that means I'm also not in Houston because Houston's not in Oklahoma. So that is a true statement. So think about the truth values for these and make sure, remember, the conditional is equivalent to the contrapositive, and the inverse and converse are logically equivalent to one another. So if the conditional creates a true statement, then the contrapositive needs to also be true. And if the converse is a false statement, then the inverse would also need to be a false statement. Example 5 does the same thing, but backwards. We're going to identify the P and the Q, and then we're going to write things symbolically. So here, if the sun is shining, then I'm outside. So this is P, if P, then Q. And then B is, if I'm outside, then the sun is shining. So that's going to be Q, then P. Is the statement from part B the inverse, converse, or contrapositive of the original statement? This is the converse because it's the switching of the two statements. So that answered that right there. Write the statement below symbolically. If I am not outside, so that's not Q, then the sun is not shining. That's not P. So that's where you flip them. You switch to the P and the Q and you negated it. That is the contrapositive. Then we have if the sun is not shining, so that's not P, then I am not outside, that's not Q, and that is my inverse. If you just negate the original P and Q, so they're in the same positions, that's your inverse. There are some fun videos online or like songs and things where you can learn to which one's the inverse, converse, and contrapositive. If you want to look those up, just Google like ways to remember inverse, converse, and contrapositive. This is just a recall. Again, I'm not going to redo the example up here because it's just a redundant example. If you do need another example, let me know. But here we have our conditional statement. This is my converse because the Q and the P are switched from the original conditional. This is my inverse because the P and the Q are just negated from the original conditional. And this one's my contrapositive because the P and the Q are switched and negated. So that's my contrapositive. Okay. Remember that these two are equivalent and these two are equivalent. You can see that in the truth table. So we can see that the original conditional statement is logically equivalent to its contrapositive. And we've said this again and again. Notice if something gets said again and again, that's probably a good sign that you need to know it. The inverse is logically equivalent to the converse. Skip down to this last example. It says, given each statement, write a logically equivalent statement. So we're going to take each of these as just a conditional. And so we're going to write the contrapositives. Okay, so if I'm in Chicago, then I'm in Illinois, then the contrapositive would be flipping these two and negating them. So if I'm not in Illinois, then I'm not in Chicago. Okay. If the stereo is playing, then I cannot hear you. So I can say, if I can hear you, because the opposite of cannot would be can. So I'm negating the cannot in writing, or I can say if I cannot not hear you, but the double negative just cancels. So I can just say, if I can hear you, then I'm going to negate this. So I negated that one. I'm going to negate the stereo is playing. So the stereo is not playing. Okay. If you don't laugh, then you die. Yikes. I didn't write this one, guys. So that's pretty grim. But anyway, we'll write the contrapositive. So we're going to start with the second one. So I'm going to say, if you do not die, then you laugh. Because the negation of you don't laugh would be you laugh. Okay, if you are diabetic, then you must have a healthy diet. So this would be if you do not have a healthy diet, then you are not diabetic. That's not necessarily true. But it is a logically equivalent statement, even if in reality we would not necessarily think that is true. It is possible to not have a healthy diet and not be diabetic. Anyway, or and be diabetic. Anyway, that's almost like a preaching, like a doctor preaching comment than one I would actually pick. But that's how we get a logically equivalent statement for that. So anyway, I hope this makes sense. If you have questions, please let me know.